look at example 3. The least root of 3x squared equals minus 6x is what? That's a question. Bring them together first. 3x squared minus 6x, bring it here, it becomes plus 6x equals 0. Factorize. 3x is common. So 3x, use it to divide 3x squared. It gives you x. This is what I mean. 3x squared divided by 3x. 3 cancels 3. X in x squared gives x. Because x squared means x times x. And when you use x to divide it, it gives you only one x left. So 3x to divide 6x, that gives you 2 equals 0. So it's either 3x is equal to 0 or x plus 2 is equal to 0. Solving this, you have x equals 0 divided by 3 or x equals minus 2. X is equal to 0. Whenever you divide 0 by any figure, the result is 0. Or x is minus 2. So finally, the least, the smallest root is minus 2. We have two roots, 0 and minus 2. And the question asks you to find the least root of the two. So the least here is minus 2. As you know, 0 is greater than negative value. Any negative value. 0 is greater than minus 1 million. Now, leaving the preliminary level of quadratic equation, we have done that. We are moving on to 3-term quadratic equation. Out of the 4 methods of solving quadratic equation, namely factorization method, completing the scale method, general method which we call quadratic method, which most of students like to call almighty formula, but God is almighty. And finally, graphical method. So we want to start with factorization method to solve quadratic equation, especially 3-term quadratic equation. We've done 2 terms. Binomial ones, we've done them. Now, whenever you want to factorize something like this, multiply the first term and last term together to get 3x squared. Now, underline the middle term. This product of the first and last term and this middle term, they are your targets. They are your targets. And most especially the middle term. How? Take the coefficient of these products, of the product of the first and last term. You know, this is a product of first and last term. Take the coefficient, take it here for analysis. What goes in this? 3 goes there, how many times? 1. Indirectly, we are extracting the possible factors of 3 in the easiest way possible. Meaning that 3 and 1, these 3 and 1, they are the factors of 3. How do we now manipulate 3 and 1 to get minus 4, which is the coefficient of the middle term? And when you get that, there is a way to test it using the products. It's okay. If you want to use 3 and 1 to get minus 4, we have to write minus 3 and minus 1. Such that minus 3 plus minus 1 gives minus 4. So we now write them in line with the variable we are using. We write minus 3x. If it is y we are using, we write minus 3y. If it is p we are using, we write minus 3p. Now we are using x as our variable. We write minus 3x minus x. That one will give us minus 4x. You know, that one has targeted our middle term. We have gotten it back. Now, to confirm that these two factors are variable, Find their product. If their product will give you this product of the first and last term, let's try. Minus 3x times minus x. These two factors that we had together, multiply them and see if you will get what is up here. Minus times minus plus 3x times x, that is 3x squared. You can see 3x squared. Positive 3x squared, positive 3x squared. So far, the two factors satisfy the two conditions of this middle term and the product of the first and last term. Then they are viable enough to be used. They are viable enough to be used. You now use them in place of the middle term. Thus, x squared, instead of writing the minus 4x, you write this minus 3x minus x. Mind you, minus 3x minus x is t minus 4x. So, you now include the positive 3 that is there, equals 0. Factorize these two, these first two. What is common to them is x. X in x squared, x. X in minus 3x, that's minus 3. Minus, what is common to this? It seems nothing is common. When it seems nothing is common, 1 is common. Mind you, put 1 outside brackets. Now, this minus 1 that you have outside, use it to divide minus x. It gives you positive x. Use this minus 1 to divide plus 3. It gives you minus 3 equals 0. Check the inside of the two brackets. You are learning this again. You have learned it under the factorization of 3-term quadratic expression. Don't forget. Now you are learning the process under the solution, under the equation. You have learned it under the expression. You are learning it under the equation. Now, x minus 3 is common to the two terms. Bring it out. Leaving x minus 1 behind, which is equal to 0. Don't forget, when two brackets multiply each other and the result is 0, it means either of the brackets is equal to 0. That is, this bracket is equal to 0, or the second bracket, x minus 1, is equal to 0. Meaning x is equal to 3 or x is equal to 1. That is, x is equal to 3 or 1. So 3 and 1 are the roots of this equation. If you are so asked, find the roots of this equation. 3 and 1 are the roots of the equation. That is the factorization way of solving this quadratic equation. Example 2. I don't know whether I've told you under factorization of 3-term quadratic expression. You know, we are dealing with equation now. I don't know whether I've told you under expression. Whether I've told you or not, let me re-emphasize it. It is not all quadratic equations that are factorizable. If you are asked to factorize a particular quadratic expression, it will be factorizable because it is an expression. Before you are given, the examiner would have known that it is factorizable. But here is the equation. It is not all quadratic equations that are factorizable. Some are not factorizable. And once they are not factorizable, what does that mean? Does that mean they have no solution? No. That means you have to solve them using any other method, but not factorization method. Please mind you. And how do you know if they are not factorizable? You will see. We will come across one of them. Now let's do this example 2. Find the other root. If a root of 3x squared minus 7x plus 2 equals 0 is 2. You know, we have two roots to every quadratic equation. One of those two roots has now been given to us as 2. One of those two roots has been given to us as 2. We are to find the other root. There are various ways, like 2-3 ways of finding that. But as it is now, let me teach you this factorization way first. As we proceed, you will learn other ways. We learn other ways. So what you have to do is just solve the quadratic equation by the factorization method. Normally, 3xk. You multiply the first term and the last term together, you have 6xk. And underline your middle term. Target them, the 6 here, which is the coefficient of your xk. Analyze it. 2 and 6 gives you 3. Can you manipulate 2 and 3 to get 7? No. Not by addition, not by subtraction. 3 and 3, 1. So harmonize this to be 6. So can you manipulate 6 and 1 to get 7? Yes. Not only to get 7, to get minus 7. Yes. If we are to get minus 7, that means we say minus 6 and minus 1. So integrate your variable. You have minus 6x and minus x. Adding them together, minus 6x minus x gives minus 7x. Multiplying them together, minus 6x times minus x gives plus 6xk. Now, this tallies with this middle term, exactly, with sign. And this also tallies with the product of the first and last term, exactly without any sign difference. That means the two factors we are using, they are variable. The two factors are variables. So using them to represent the middle term is the next thing we do. So we write 3xk. Instead of writing minus 7x, we write minus 6x minus x. So we write 2 alongside. Factorizing these two terms, 3x is common. 3x and 3x gives x. 3x and minus 6x gives minus 2. Minus. You write this sign first. What is common to these two terms? It seems nothing is common, but 1 is common. Write the 1. Open bracket. Minus 1 here. Use it to divide minus x. It gives you plus x. Minus 1 here. Use it to divide positive 2. It gives you minus 2. Equals 0. Equals 0. So, factorizing this out, you have x minus 2 into 3x minus 1 equals 0. Don't forget, it's either x minus 2 is equal to 0 or 3x minus 1 equals 0. Solving each linear equation we have there, you have x equals 2 or 3x equals 1, while x equals 1 over 3. Therefore, x is equal to 2 or 1 over 3. You get two roots now. But mind you, you have to find the other root. One of the two roots you get now has been given to us, which is 2. And see it truly there. So which one is strange that you are required to find? 1 over 3. You now write, therefore, the other root is 1 over 3. And that's the end of that question. Example 3. Find the roots of 2sk plus x plus 3 equals 0 still by factorization method. Multiply the first and last term together, we have 6xk. Underline the middle term. So 6, 2 here, 3. Can we manipulate 2 and 3 to get the middle term? The coefficient of the middle term? Yes. That is by having 3 minus 2. 3 minus 2 will give us 1. Good. But can 3 times minus 2 give us this? This is minus 6. And mind you, this is plus 6. That is not factorizable. That is exactly how to know that something is not factorizable. Because 3 minus 2 gives us 1. If you were to adapt the variable, we have 1x, which is x. Meanwhile, the product, which is minus 6, if we are to adapt the variable, we put the variable there, and the variable of that will be x squared. If we put it there, this is positive 6x squared, this is negative 6x squared. They are not the same. They should be the same in terms of sign. They are not the same. And it's not, you are not the one making your own personal mistake, then it is not factorizable. Mind you, if you are making your own personal mistake, it will not be factorizable to you, and you are the one making your mistake, but you have to be sure you are not the one making your own personal mistake so as to conclude wisely that it is not factorizable. So we leave it. We leave it. To have the solution of this, we have to use one of the other, any of the other methods, which is not our business here now. So let's go to example 4. Now, the last example I am giving you for today on this. Find the root of x squared minus 2x plus 1 equals 0. By now, everybody should be able to do that, but let's do it together. Multiply the first and last term together, that gives you x squared. You know, if you write 1x squared, there's no crime, but it shows that you are an amateur. So you underline the middle term. The coefficient of this coefficient of x squared, bring it out. It's your business. It's what you have business with. What goes in 1? 1 goes in 1 time. That shows clearly that all the possible factors you can have here is 1. After the 1 is still 1. 1 and 1. So 1 is the factor. So you now write 1. If you write 1 plus 1, that is positive 2. Therefore, you must have minus 1 to give you minus 2, which is the coefficient of the middle term. If you adapt the variable, you have minus x, which is minus 2x. Can you see the middle term showing clearly? So test if the product of the two of them can give you the product of the first and last term. Minus x times minus x gives you plus x squared, which is this. Can you see? Plus x squared is the same thing as 1x squared. So that means these two factors are viable to use. Bring them out. X squared, in place of the middle term, use minus x. Now bring the plus 1 equals 0. What is the common factor to these two? That's x. X in x squared is x. X in minus x is minus 1. Minus. Write your minus first. What is common to x and 1? It seems nothing is common, but 1 is common. Put 1 outside. Minus 1 you have outside here. Use it to divide minus x. It gives you positive x. Use the minus 1 to divide plus 1. It gives you minus 1 equals 0. The inside of the two brackets must be the same without any discrepancy. So, you factorize x minus 1 out because it's common to the two terms. You have x minus 1 into what is left here, x. What is left here, minus 1 equals 0. Don't forget, it's either x minus 1 is equal to 0 or x minus 1 is equal to 0. So, you have x is equal to 1 or x is equal to 1. You see, x is equal to 1 twice. X is equal to 1 twice. It's equal to 1 twice. That is, the first root is 1, the second root is 1. So, that is the end of this. I want to believe you understand the nitty-gritty of solution of quadratic equation using factorization method. Thank you. So far, so good. We've been able to do justice to solution of quadratic equation using factorization method. And I'm happy you get it. But to assure me that you get it, try your hand on these assignments. And when next we meet, we have the solution to juxtapose and see if you are correct. Thank you. God bless you. Make sure you do it.